Hey guys, this question asks, which of the following compounds would have the highest RF value during thin layer chromatography? All right, so I'm going to go through the basics of TLC just quick. You have a little glass plate, and on that little glass plate, this glass plate is coated with silica gel all over like this. And then what you end up doing is, I'm just going to redraw it for a second, is you will pull with it, you use a pencil usually, and you pull a little line over there. Okay, and then what you do is you spot, so you have, like, say, your reaction mixture or whatever compounds you're trying to move. You'll take those and you have a little capillary tube, a tiny little tube, or sometimes people make the little tubes just from pipettes. And they take that and you dip it in your compound, and then you just spot it onto the compound, onto the TLC plate like this. And it'll make a little dot there where the compound has been spotted. And then what you do is you take your TLC plate and you put it in a beaker just high enough so that the solvent, and there's solvent in the beaker, is slightly below that pencil line. You don't want the spots to be submerged into the solvent, because then they'll basically dissolve into the solvent. You don't want that. Now, slowly but surely, this solvent will pull up into the TLC plate all the way up slowly. You can watch it. It kind of goes very slowly, but it takes about 2 minutes or so, 3 minutes, and it pulls all the way up, and near the top you stop it. You pull the plate out right before it gets to the top. You don't want it to go all the way to the top, okay? And then what you do is you basically measure the distance that these guys travel. So say, for example, this dot here traveled till there. Then you take this distance and you divide that by this distance that the solvent traveled. And that'll give you a fraction, 0.4, 0.5, 0.7, whatever. If the spot moved all the way with the solvent, then that would be an RF value of 1, right? Because it would be, whatever this distance is divided by itself. So the higher the RF, the bigger the RF value, the further the compound traveled. So now, a compound that will have a really low RF value, in other words, the spot didn't move much at all, will be a compound that binds to the silica gel really strongly. And silica has these oxygen groups on them. And those oxygens, they can hydrogen bond with other compounds. So compounds that typically move really high, really fast are nonpolar things like a hexane molecule or benzene or things like that. Now let's look at our answer keys here. We have a lot of compounds that can hydrogen bond, that are really polar, that will interact with the silica gel very strongly. Things like A, C, D, and E. That carboxylic acids, actually, they kind of streak. When they pull up very slowly, and they make these little streaks like that. Usually you can counteract that by putting a drop or two of acetic acid into your solution. So these compounds will all move really slowly and have very low RF values, whereas toluene here is not going to bind to the silica gel almost at all. So that'll pull up the TLC plate very fast. So the correct answer here will be answer choice B, without a doubt. It's not even close. All right, guys, make sure you understand your lab techniques very well. I suggest to people, when they struggle with them and they kind of don't understand how they work, watch videos on YouTube. Watch people actually do the experiment, because then it makes a lot more sense if you have that picture in your mind of what does the glassware look like, what does the TLC plate look like, etc., etc. The best experience you can get to learn this stuff is simply to work in an actual chemistry lab. That's the best experience you get. But if that's not available to you right now, or you don't want to spend that kind of time, just watch the videos on YouTube and you'll pick it up very quickly. Thanks for watching, guys. We'll catch you in the next video. If you have any questions, send us an email to Champion Tests, and we'd be happy to get back to you with more detailed explanations of whatever you have a problem with. Good luck with your studies, and have a nice day.